Alright, Algebra 2 Trig Honor students. So this one is just a continuation of the review packet. So for chapter 10, so we'll talk about probability, regular probability, conditioning probability, and also overlapping disjoint events, and also the probability for independent, dependent. So let's start it off with the basics. So normal definition of probability is always the number of outcome in the event divided by the total number of outcome possible. So let's say that if you choose one marble at random, so what's the probability that it's red? So let's say we do have four red marbles, and 3 are blue, 2 are green, and 1 is yellow, so total is 10. So the way to come up with that, this one's pretty basic, so it's 4 over 10. So there's only one thing involved right here, so selecting the red marble. And choosing that one marble randomly, so what's the probability that's red or blue? So getting red or blue, the keyword's or. So the keyword is or, that means it's considered addition. So getting the red marble, so then that'll be what? 4 over 10. And getting the blue marble, then that'll be 3 over 10. So once you combine them, then that'll be considered 7 over 10. If you choose two marble in sequence without replacement, so what's the probability that you choose a blue and then a green? So choosing the blue, then 3 over 10. And the keyword right here, so it looks like it's considered addition. Well, but the thing is that and, then that would be considered the multiplication. So or, that's considered additions and multiplication. So since we pick one of those, so there are only 9 of those marble remain. So 2, 9. From the 9 marble, we need to select two of those marble, which is considered, and they're considered green. So 3 times 2, 6, 10 times 9, 90. So it's 1 over 50, or 0.06 bar. And then this one is quite similar. But now let's talk about the conditioning probability. If you choose two marble at the same time, okay? So this one tells you you're choosing two marble at the same time. And what's the probability that you choose a red and yellow? So let's find out how many marble that we need to select right here. So 10, choose 2. From the 10 marble, we need to select 2 of those at the same time. So the total outcome here, 10, choose 2. So in order to select the red marble, so it's 4, choose 1. And what else? Times 1, choose 1. Because the other one, you want to choose a yellow marble. There's only one yellow marble, so 1, choose 1. So multiply it out, expand it, combination, so 2 over 5.4. So anytime that I see anything that's considered like two things happen at the same time, or you have to do it with all those events together, so that means it's always considered conditioning probability. So here's another one. If you choose two marble at the same time, conditioning probability. And what's the probability that they're both blue? So 10, choose 2, and there are only 3 blue marble, but 2 of those gotta be, both of them gotta be blue. So 3, choose 2. So expand it, multiply it out, and then you got 1 over 50. If you choose 3 marble at the same time, 3 marble at the same time, conditioning probability. So anytime that you do have more than one event happen at the same time, so that's always considered conditioning probability. So what's the probability that you choose 2 red, 1 blue? So 10, choose 3, because we want to choose 3 marble from those 10 marbles. And 2 of them got to be red. So 4, choose 2. And then one of those got to be blue, since we do have 3 marbles. So 3, choose 1. So 4, choose 2, times 3, choose 1, over 10, choose 3. So 3 over 20. So if you choose 2 marble at the same time, what's the probability that they are both yellow? Well, this one, there's only one marble is considered yellow, but you have to choose 2 of those. Then the chances right here, then that'd be 0. There's only one yellow marble. Okay, so again, if you choose one thing, so that's just considered one event happens, so that's just like a normal probability. If anything, that's considered 2 or more than 2. So that's considered conditioning probability. So if you choose 2 letter at the same time, so what's the probability that they are both consonant. So consider the word compute consonant. So we do have 4 of those consonant, and we have to select 2 of those. And how many letter can we pick? So 7, and we have to choose 2 of those. So 7 choose 2, so the total possible outcome. And then 4 choose 2, so then that would be the possibility. Divide it, then that would be 2 over 7. So the rest of this, they're quite similar. And here's the one for the standard deck of cards. If you choose one card at random, what's the probability that's a face card? So face card, how many of those face cards do we have? 12 over 52, so then that'll be 12 over 52, or 3 over 13. You choose one card random, find the probability that the card is hard or spade. Okay, again, the key words or. So the card is considered either hard or spade. So 13 over 52 plus 13 over 52. Then that'll be considered 26 over 52. And once you reduce it, then that'll be 1/2. So you choose 2 cards at random, find the probability that the cards are both hearts. So both cards are hearts. So 13 choose 2. So 2 cards must be heart. Over 52 choose 2. So it's 1 over 17. So a 5-card poker hand is drawn. So what is the probability that all 5 cards are black? Okay, so black cards, so we do have 26 of them. And 5 of them gotta be... Okay, so 5 cards gotta be chosen right here. So 52 choose 5. And then 26 choose 5 over 52 choose 5. So 26 black cards, choose 5 of those. Over the total possibility, 52 choose 5. So divide it, so it's about 0.0253. Again, the rest of this, so for the cards, they're quite similar. And now to look at that 22 here. So a 5-card poker hand is drawn. What is the probability that all 5 cards are from the same suit? So first thing that you want to do, you want to pick one suit first. So we don't know what that is. Could be diamond, could be spades, could be club, could be what? Could be heart. So 4, pick 1. The order does matter. And then 13 choose 5. So 13 choose 5 because that all those 5 cards coming out with the same suit. So 13 choose 5. And then it's all over. 52 choose 5. So eventually it's 0.00198. Okay, so gotta be careful with the key phrase right here, from the same suit. So 4, pick 1. So make sure that you pick the suit first. And then for those 5 cards, you can choose them randomly from those 13 set. And for the rest of this, Emily has 6 bangle bracelet, excuse me. And then 7 silver, 4 golds, 3 witch crystal, and 2 with charms. Okay, so this one, 24th, Emily select 2 at random to wear on Tuesday. So what's the probability that she chooses 2 crystal bracelets? So 3 choose 2 over 16 choose 2. Okay, so 3 crystals, so 3 choose 2 of them. And then all over 16 bracelets totally. So 16 choose 2, so 1 over 40. So it's all about the conditioning probability. So here's another one. So Emily select 4 at random to wear on Thursday. So what's the probability that she chooses 3 silver? That she chooses 3 silver bracelets and 1 bracelet with charm. So 7 choose 3 times 2 choose 1 over 16 choose 4. So it's 1 over 26. And then here's another classical examples. So a case of tennis ball contains a dozen cans of 3 tennis ball. 5 tennis ball in the case are defective and don't bounce. So 1 ball is selected at random. So what's the probability that's defective? So 5 out of 36. If one ball is selected random, so this one there's no conditioning, so because that's only one thing. So what's the probability? That's not defective, 31 over 36. But here's the one, conditioning. So two balls are chosen at random. So what's the probability? That both are defective. So 5, choose 2, over 36, choose 2. And then this one is quite similar. So 32, if 5 balls are chosen at random, so what's the probability? That 2 are defective. Okay, so 2 of those are defective, so 5 choose 2. And then the non-defective, then that'll be 31 choose 3. And then all over, 36 choose 5. Again, it's all about the conditioning probability. Even the one that's considered non-defective, you still need to multiply it. Because this one is coming out from the total possibility. 36 choose 5. So identifying permutation combination, we talked about that previously with the binomial expansion. So check the previous video. And the compound probability, so disjoint and overlapping events. So if A and B are events, then the probability of A or B is always written as this. So let's say that A and B, they're not considered disjoint if they're overlapping. So let's say that if they're overlapping, we need to find out the one they share in common with the Venn diagram. So we need to subtract that, the overlapping probability. So probability of A plus the probability of B minus the probability of A and B they share in common. So two events cannot occur at the same time, so they are called mutually exclusive or disjoint. So therefore, probability of A and B happen together, so the chances would be 0. So a standard deck of 52 cards, one card is drawn at random, so find each probability. So probability of getting an ace or 5. Again, the keyword or, that means addition. So this one that related with the overlapping, because that from the ace card. Well, let's see, from the ace card. So we got 4 of those. Oh, you know what? There's no overlapping event here. Ace card is what? Just the diamond, spades, heart, and club. And then 5, it's also the same thing. So there's no overlapping event here. No card they share in common. So it's just 4 over 52 plus 4 over 52. So it's 8 over 52. So 2 over 13. But here's the one. So the spade card or 2. So one of the spade card is considered 2. So that's considered overlapping. So 13 spade plus what? How many 2? 4, 2. So 13 over 52 plus 4 over 52 minus 1 over 52. So this one is considered overlapping. So 16 over 52. So then that'll be 4 over 13. And then the heart or the face card. So the heart that involved with 1, 2, 3, 4, 5, 4 face card. They all consider heart. Okay. So for the heart, so it could be 13 over 52. And then for the face card, then that'd be 12 over 52 minus 3 over 52. Oh, the jack, the queen, and the king. It's only 3 of them, which is also the heart. So the heart king, the heart queen, and the jack. So 3 over 52. So overlapping. So 13 plus 12 minus 3, 22 over 52. 11 over 26. And this one's quite similar. 7 and queen, they have nothing in common. So we just subtract 0. So just 4 over 52 plus 4 over 52. So 2 over 13. So rolling a die. So this one we talked about that already. So in order to get even numbers, so 3 over 6, 1 or 6. So 1 6 plus 1 6. So 1 third, 2 over 6. Even or prime number. So the even or prime number, we do have 2, 3, 4, 5, and 6. Okay, so we got 3 even, and then 2 prime, so it's 5 over 6. So this one can be done by 3 over 6 plus 2 over 6, because the keyword is what? Or. And they had nothing in common, so minus 0, 5 over 6. And the probability of multiples of 2 or multiples of 3. So the multiples of 2, we do have 2, 4, and 6. And then the multiples of 3. Okay, so the multiples of 2, then that's 3, 4, and 6. So 3 over 6. And the multiples of 3, then that would be considered 3 and 6. So it's 2 over 6. And one of those is overlapping because the 3 that we use it twice. So minus 1 over 6. So therefore it's considered what? 4 over 6. Reduce it, so it's 2/3. Okay, so the rest of this, they're quite similar. So again, you want to decide what they have in common. If there's nothing in common, that means consider non-overlapping or disjoint. So 2 marbles are simultaneously drawn at random from the bag containing 3 red marble, 5 blue, 6 green. So again, if anything that's considered more than 1, it's always considered conditioning probability. So what's the probability at least 1 red marble? So we got 3 red marbles, so one of those got to be red, at least 1. So 3 choose 1 times 11 choose 1. Well, because for the other marble selection, so since we pick 1 red, so that means the rest of the color, so it got to be what? 11 marbles remain. 11 choose 1, all over 14 choose 2. So this one is saying that at least we choose 1 marble. What happens if we choose more than one red marble? So 3 choose 2, over 14 choose 2. Okay, so at least 1, so that means it could be 1 or 2. Or 1 or more than 1. So the next one, probability of selecting 2 marbles of the same color. So 2 marbles from the same color, so then that'll be considered either both of them are red, or both of them are blue, or both of them are green. So 3 choose 2, plus 5 choose 2, plus 6 choose 2, over 14 choose 2. So then that'll be 4 over 13. Okay, so the rest of this, they're quite similar. So rolling the die. So getting the sum is 8. So you want to list all the outcome and find out the number of chances to get that number. The sum is 8. So the total possibility is 36. And then you want to find out the sum, which is 8. So 5, 3, 6, 2, 4, 4, 3, 8, 3, 5, 2, 6. So it's 1, 2, 3, 4. So it's 5 over 36. And find the sum is less than 5 or greater than 10. So the sum is less than 5, so which is what, 6 of them? And the sum and greater than 10. So the sum is less than 5 or greater than 10. So greater than 10, then that'll be 3 of those. Right here, the last 3. So combine them all together, so 6 over 36. Or, that means additions, 3 over 36. So 9 over 36, 1/4. And finally, independent-dependent probability. So 2 events are independent if the outcome of the first event does not affect the outcome of the second event. 2 events are dependent if the outcomes of the first event does not affect the outcome of the second event. Okay? So the way to come up with the independent-dependent probability is the keyword and. That means we multiply. So probability of A and B. So it's just probability of A times probability of B. So 2 cards are drawn from a standard deck of cards at a time. find each probability if there's no replacement occur. So getting a jack, the second one getting the jack again, so 13 over 52 times 12 over 51. The reason why that's 51 because without replacement, since you select one card for the first time, so you cannot select the same card for the second time. So you're not going to put it back to the deck. So it's 1 over 17. Getting the heart and the club. So 13 over 52 times 13 over 51. Again, once you select the heart, you cannot put it back to the deck of the card. And the rest of this, they're quite similar. So example 7, 8, 9, and then the rest of this. So the majority of them, they're considered independent or dependent event to find the probability. So it's quite similar to the one that we did previously. Okay, so let's take a look at that one. So Monica has 7 blue pens, 3 black pens, and 2 red pens in her decks. If she selects 3 pens at random with no replacement, without any replacement, so what's the probability that she would first select a blue pen, a black pen, and then another pen? So 7 over 12, okay, times 3 over 11, because the next selection is getting the what? Is getting the black pen. It's only 3 of those. But for the first selection, so she want to get the blue pen. So 7 over 12 times 3 over 11. As you can see that the denominator, the number is getting 1 degree less. Well, the reason why is that because once you picks one pen, and then so you want to find out the rest of those total remain. So 7 over 12 times 3 over 11 times 6 over 10. And contestants on a game show reaches into a container without looking and picks 2 paper bill, and their $200 bill, $450 bill, and $20 bill, and 10 bills, $10 bill. And what's the probability that the contestant draw 2 $10 bill, one after the other without replacement? So the first time he was doing it is 20 over 36. Okay, so 20 over 36. And then the second time doing it without the replacement, so 19 over 35. So once you multiply them, so it's 19 over 63. And then the rest of this is quite similar, conditioning probability. Find the probability of drawing face card, and then, again, the keyword, and then, an ace card from the standard deck, 52 card deck. With replacement, without replacement. With replacement, then that's pretty straightforward. It's 12 over 52 times 4 over 52. Without replacement, so whatever that you have for the first fractions, the second one, you always want to subtract the total outcome by 1. So it's 4 over 51. Again, so drawing a face card, then an ace card from the standard deck. So face card, we got 12 of them. Without repeating it, so for the ace card, we still have 4 left. So 4 over 51. And then the rest of this is just a mixed review of conditioning probability with combinations, like what we talked about for the previous video. And more counting principle with permutations, the one we talked about earlier. Okay, so that's it. Alright, thank you for watching the video today. So I'll see you guys next time. You guys take care. Bye.